So, hello everyone. Today we are going to learn about the basics of the chapter Strength of Materials, or also called Mechanics of Solids. So, as we are engineers, as we know, we are all engineers. So, it is in our hands to design, build, product, manufacture, and use technology effectively in this modern world for our lives to go parallelly with it. As we all know, the situations or circumstances prevailing now are very much modernized now. So, in order to cope up with or go contemporary with the prevailing situations, it is in our hands to use the technology or and use our knowledge efficiently. So, there would be no failure. So, coming to strength of materials, what is strength? Strength, as we all know, that strength means the feeling of some strong, or that we could do anything, or we could resist hard or any attack. Yes, strength of a material means the resistance of the material to failure. Yes, strength means the ability of a material to failure is called its strength. From the observation, it has been known that the deformation occurs gradually. When external forces are acting on a body, the deformation occurs gradually and failure takes place. The deformation is not sudden, it is a gradual process till failure, then the failure takes place at a certain point. So, the study of the external forces and the effects and the safe working conditions of the materials is called strength of materials. So, moreover, these are mainly applied to metals only. As we know, metals are a major component in our lives that have been in use from the old ages to till now. We know that there's nothing that we could do without a metal. So metal is a very much important and essential component of our lives. So we should apply the strength of materials to metals only. So coming into the basics, first foremost thing we should know is the stress. What is stress? Stress, as we all know, we all have stress. Stress means some external, if we have an external burden, then the inner feeling we develop is called stress. Moreover, applying to this subject, stress is similarly, this is an object. Yes, an external force is being applied here. As the external force is applied here, according as we all know the Newton's third law, for every action there is an equal and opposite reaction. The same applies here. For the external force being applied here, let this is being F. There is a resistance developed in the interior of the body which resists the applied external force. This is nothing but stress developed in the body. Stress in common terms is nothing but resistance per unit area. Resistance that has been developed per unit area is called stress. So it is represented by sigma. Stress is force per unit area, or P means load per unit area, and its units are Newton per meter square. So stress is nothing but resistance developed in the inner part or interior of the body for the external force being applied is called stress. If the force is greater than the stress, then deformation takes place. The body deforms. If the force is equal to the stress, then the deformation do not takes place, and the body will be firm as it is before. So it is called stress. Coming to the second one, it is strain. Strain, as we all know, if a force is applied on a body, deformations takes place. Yes, suppose this is a body. Force is applied here at both the ends, so the body contracts like this. Of course, like this, or the body may elongate like this from the original one, depends upon the force. So strain means the deformation occurred in the body, or the deformation per unit length occurred is called strain. So strain is equal to, it is also written as a change in length to the original length. Of course, change in length to the original length is called strain. Strain do not have any dimensions, as here it is length and here it is length. Both have same units. Those will be cancelled and it is unitless. So once again, strain do not have any units and it is dimensionless. So strain is nothing but change in dimension per unit length, or change in dimension to the original dimension. It is called strain. Yes, now you got familiar with these two facts. Coming to elasticity. Yes. What is elasticity? As we all know, if you take a rubber and elongate it, suppose it is a rubber. Sorry, the rubber looks like this. Yeah. If we elongate it, as we all know, it elongates. If you remove the external force, it comes to its original position. So that property is nothing but elasticity. When the body returns to its original shape and size, when the body returns to its original shape and size after the removal of external force, that property is known as elasticity. So it is a very familiar property for all of us. So next, coming to stress and strain diagram. Stress versus strain diagram. Stress versus strain diagram. So what is stress versus strain? Let's draw a graph here. First and foremost thing is, stress versus strain diagram varies for different metals. So it would be different for mild steel. It would be other for carbon steel, low carbon steel. Now I'm considering for mild steel. For example's sake, this is stress and this is strain. As we see, the stress is directly proportional to strain to some extent. Up to this point, I would say, which is called. So this is a stress strain curve, and it is the point of fracture. So naming it as A, B, C, D. So A here means elasticity limit. Here the stress is directly proportional to strain. Until here it is called elasticity limit. Point B is called yield point. Yield point. Yield point means from B the gradual deformation occurs plastically. This is 0. From 0 to B, when the load is applied, the body deforms within the elastic limit elastically. Means if the external forces are removed, then the body regains its original shape and size. So after B, when the load continues on the object, then the body deforms plastically. Point C is called ultimate strength. And point D is called fracture point. So understanding the diagram, it is the stress versus strain curve of mild steel. So as the load is applied on the object, the stress strain curve shows a linear curve. Means stress is directly proportional to strain under elastic limit, that is point A. So again, when the load applied is continued gradually, it attains point B, which is called yield point. So at yield point, after yield point, the body gradually deforms plastically. Before yield point, the body deforms elastically, means it would regain its original shape and size after the action of external forces. But after the yield point B, the body deforms plastically. That means it do not regain its original shape and size. When the load is applied continues gradually, then the point C would occur, which is the ultimate strength. Means it is the ultimate point which the body could take the load. When the load is applied continuously again, it would reach the point D, which is called a fracture point, or the point of failure, where the body finally breaks or fails. So it is the stress strain curve of a mild steel. So coming to some Hooke's law. Hooke's law. Hooke's law is nothing but stress is directly proportional to strain within elastic limit. It is called Hooke's law. So if we draw two perpendiculars at the elastic limit, it is the strain, it is the stress. I would explain the significance of it. So if we remove the proportionality, then it would become a constant. This E is called modulus of elasticity. Elasticity. Yes. Hooke's law states that stress is directly proportional to strain within the elastic limit. It is called Hooke's law. Coming to resilience. What is resilience? What is resilience? As you have seen here in the stress strain curve, this is stress, this is strain, it is stress. Stress is directly proportional to strain within the elastic limit. It shows a linear curve. So resilience means the energy stored within the body under elastic limit is called resilience. So the energy that is stored when the load is applied on the body, when the energy stored under elastic limit is called resilience. So how to find out resilience? Resilience is nothing but, take this triangle. As we all know, it is stress and it is strain. So the area of this triangle is called resilience. So resilience is nothing but half, base is strain, height is stress. So sigma into strain by 2. This is called resilience. Now you got familiar with the stress strain curve, Hooke's law, and resilience. So Hooke's law is when stress is directly proportional to strain within elastic limit. If we remove the proportionality, we get the constant known as modulus of elasticity. And resilience is strength or energy stored within the body under elastic limit. So I think it is clear from till here. So coming to some stresses. So first we take tensile stress. What is this tensile stress? Suppose we take a body. If we apply force, two equal and opposite forces in opposite direction, then the body elongates. It becomes like this. Before, after. So this is called tensile. If we apply two equal and opposite forces at both the ends, it is called tensile force, and the stress developed corresponding to tensile force is called tensile stress. So the corresponding strain is called tensile strain. Now coming to compressive stress. So let us take a body. If two equal and opposite forces are acted in the same direction, then the body tends to compress, means it would become somewhat like this. The cross section area decreases. Yeah, it's a rough figure. This is before and it is after. So it is called it is called compressive force, and the stress developed within for the corresponding compressive force are called compressive stresses. So the corresponding strain is called compressive strain. So when the two equal and opposite forces are acted against each other in opposite direction, it is called tensile force, and the corresponding stress and strain are called tensile stress and tensile strain. When two equal and opposite forces are acted in the same direction, then the force is called compressive force, and the corresponding stress and strain are called compressive stress and compressive strain. So coming to now shear stress. Shear stress. Let us take an object. If two equal and opposite forces are acting at the tangential surface of an object, then then the object is in shear. So these are called shear force. Shear forces. When two equal and opposite forces are acting at the tangential part of the body, then the force is called shear force. Then the stress developed would be shear stresses, and the strain would be shear strain. So now you are familiar. See, two forces, let F, two equal and opposite forces are acting on the tangential part of the body. Then the object tends to shear in both the directions. Then the stress developed are shear stress, and the corresponding strain is called shear strain. So moreover, what is modulus of rigidity? Of rigidity. Modulus of rigidity is nothing but shear stress by shear strain. The ratio of shear stress and shear strain is called modulus of rigidity. See, shear stress is represented by tau. Shear strain phi. So modulus of rigidity is equal to tau is directly proportional to phi. So tau is equal to G into phi. G is equal to modulus of rigidity. Yes. Sorry, here, modulus of rigidity. Tau is directly proportional to phi. Tau, if we remove the proportionality constant, it would become G. G is nothing but modulus of rigidity. So coming to bulk modulus. Bulk modulus. Bulk modulus, suppose for understanding bulk modulus, we should understand volumetric stress and strain. Suppose let us take a cube. Cube, if it is immersed in water, then it would experience perpendicular forces from all directions on its faces. So it would compress volumetrically. So these forces are called volumetric forces, and the stresses developed within are volumetric stresses. And the corresponding strains are called volumetric strain. Volumetric strain. So if a body is immersed in the body water, then it would experience perpendicular forces and on all its faces equally. Then the corresponding stresses developed are called volumetric stresses, and the corresponding strain is called volumetric strain. So what is bulk modulus? So bulk modulus is a ratio. Bulk modulus is represented by K is equal to volumetric stress by volumetric strain. It is called bulk modulus. Now you got the picture of bulk modulus. Coming to Poisson's ratio. Poisson's ratio. What is Poisson's ratio? To explain Poisson's ratio, we must know about lateral strain and linear strain. First, lateral strain. Suppose if a body is elongated, as in case of tensile forces. Yes, the strain developed laterally or in transverse direction is called lateral strain. And the strain developed longitudinally in these directions. Sorry, here, and longitudinally here, like this. It is called longitudinal strain. So laterally means transverse. Strain developed in this direction is called a lateral strain, and this direction is called a longitudinal strain. So Poisson's ratio is nothing but lateral strain by longitudinal. So coming to the relation between the elastic constants. So relation between elastic constants. First one, E is equal to 2g into 1 plus 1 by m, or 2g into 1 plus mu. So second one, E is equal to 3 into k into 1 minus 2 mu. And third one, E is equal to 9gk by 3k plus g. So these three are the relations between the elastic constants, that is modulus of elasticity, modulus of rigidity, and bulk modulus. So hope you have gained a knowledge about some basics of this chapter, strength of materials, that is stress strain, stress strain curve, elasticity, Hooke's law, shear stress, volumetric stress strain, Poisson's ratio, and all. So stay tuned for another updates on this chapter and other works. So that's all for today. Have a good day. Bye.